Today let us study how the factors and the zeros of a polynomial are related. But then the first question is, why are we making it into factors? What is it now? It is in terms. It is separated by a plus sign or a minus sign. Why do we need factors? Let us first answer that question and then see what the relation is. This is how your polynomial of the degree 2 looks. For sure it will have an x square term, but the x term and the constant term, that is like it depends. You may or may not have it. But here onwards our method changes. From the term form we will change it into a factor form, which means we will change into something which looks like this. Why is that? All the identities that we have studied do the same thing, right? Look at this identity. Here, these are the two identities that we have learnt in the earlier classes. What do you actually see here? On one side we have terms, 1, 2, 3, 3 terms. And here what do you have? You have factors. There is a multiplication sign here. You have two terms which are separated by a multiplication sign equated to something separated by a plus sign. Here also you have the same thing. Two factors here separated by a multiplication sign equated to two terms separated by a minus sign here. Now if both of these are equal, we have an equal to sign, right? The LHS and the RHS are equal. We are talking about the same number, but here expressed in something into something, and here expressed in plus and minus. Why is it important? Because the properties of multiplication and the properties of addition are completely different. They both are operations on numbers, but their properties are completely different. From the degree 2 onwards, always try to factorize it. It will be easier for you. Why is it easier? Let me explain it to you. Now you have two equations here. One where we have added two numbers. Can you tell me what this A and B can be? Can you tell me what A and B will satisfy this equation? I can find a millions of answers for this. 7 and minus 7, 2 and minus 2, 3 and minus 3, and any number. There can be millions and millions of two numbers which satisfy this equation. But then come to the multiplication, only two cases you have to consider. Either your A will be 0 or your B will be 0. Only two possibilities. Why is that? Because you cannot multiply two non-zero numbers and get 0. This is impossible. So if you are multiplying two numbers, that means either this is 0 or this is 0. So you are talking about only two possibilities. That is why when it comes to equating something to 0, we are finding the 0, right? When you have to equate something to 0, it is always better to take it in the into form or in the factor form, so that you have only two possibilities. Now let us see few cases. Now here are some polynomials, all of them in the degree 2, all of them in the term form. Can you find what x will make this 0? How will you even start? If you start with 1 and then 2 and then minus 2, you will be sitting here the whole day. There is no way that in the term form you can find an answer quickly. So what do? You split the middle term and make it into factors. And you have already studied how to do it, right? I have already done that splitting the middle term thing. So please refer to it. And how do you do that? So there, from the term form, you have made it into the factor form. You can check this. 7 plus 2 will give you 9. 7 into 2 will give you 14. So you have made it in the factor form. Now, if you were to equate it to 0, then how will this work out? Either this will be 0 or this will be 0. That means either x plus 7 is equal to 0 or x plus 2 is equal to 0. That means either x is equal to 7 or x is equal to minus 2. These are the only two roots you can find. Is that all? Yes. That is all. Why is that? Because any polynomial, if you know its degree, that is the maximum number of zeros that it can have. That means if its degree is 2, maximum it can have 2 roots. What do you mean by the word maximum? That means it cannot have 3, 4, 5, 6, etc. And it also means that it can have only 1. It can have even 0 roots. That is fine. It just cannot be more than 2. Shall we see 2 examples where you have only one root and you have 0 roots? Let us check that out. Now I have written down 3 polynomials. What do you notice is common among them? All of them are of the degree 2. Let us see how many zeros each one of them has. So what do? We start by factorizing them, breaking them into factors. From that you will get the zeros. So shall I start with the first one? In what form do you see it? It is again in the a minus b whole square form. Now it is in the a minus b whole square form, that is here x minus 2 the whole square, breaking it into 2 factors, x minus 2, x minus 2. Then what are the zeros? Just one zero repeated 2 times, 2, 2. But I don't have to write it 2 times, right? I'll just write 2. It has only one zero. And what is that zero? That zero is 2. Now go to the second one. What form do you see? You see only 2 terms, a square minus b square form. Then how do you break that into? There. 2 terms, a square minus b square, which means what? A minus b, a plus b. From that, the first one you get the 0, 2, second one you get the 0, minus 2. How many zeros here? You have got 2 zeros here, 1 0 here, and now let's check out the last one. Now we have a bit of a sticky situation here. What is happening here? X is square root of minus 4. That means what will make this whole thing into 0? Only square root of minus 4 will make this 0, but we have a problem there. Square root of minus numbers, the square root of negative numbers is what? It is not a real number. What are real numbers? Real numbers are all the numbers you have studied until now. Natural numbers, whole numbers, integers, rationals, irrationals, all of them are included. Please check out. I have done this in one of my earlier videos also. Please refer to it. All of them are real numbers. Then what is not real? Anything that is not a real number is known as a complex number. This is just an example for it. A square root of a negative number is not acceptable. So that means it does not have any real roots. Its root is actually a complex number. It falls out of the real number realm. What do you see here? You see 3 different polynomials, all of degree 2, but having different number of zeros. Now this is the result that we want. If x plus a is a factor of p of x, then minus a is a 0 of p of x. Let us take a very simple polynomial and see if this is true. Now this is the polynomial using which we are going to prove this result. It was in the term form. I have made it into the factor form. How? By splitting the middle term. I have got 2 numbers, 1 and 2, which when multiplied give 2, which when added give 3. So splitting the middle term, I have put it like this, and I have already done a video on that. So please check that out for reference. So this is how we have 2 factors. Now what does our result say? If x plus a is a factor, then minus of this should be a 0. Is it a 0? Check out for yourself. Now, wherever there is x, if you put a minus 1, this is your answer. It reduces to 0. What does that mean? Minus 1 is a 0. Now look at the next factor. It is x plus 2. What is its 0? Its 0 is minus 2. Minus 2 plus 2 will give you 0. Now, is this minus 2 a 0 of this bigger polynomial also? That is what we are going to prove, right? The 0 of the smaller factor is also the 0 of the bigger polynomial. Is it a 0? Wherever you have x, put minus 2 and see if you get 0. It is plus 4. Whatever is squared, it becomes plus. So there. Did you get 0? There, you have got it. What does that mean? Whatever is the 0 of the smaller factor is also the 0 of the bigger polynomial. Now it works both ways. This is an if and only sign. Not only from this you get this, it works the other way also. What does that mean? Let us check out. Now we are going to prove that it works this way also. Randomly take any polynomial. I have taken this x square minus 2x plus 1. And 1 is a 0. You can check for yourself. Put wherever you have x, put 1 and see, you will get 0. So A is a 0. Now what is our question? Is x minus 1 a factor? Is it a factor? Of course it is. Look at what form it is. It is in the a minus b the whole square form. It is a square and then a b square. 1 you can write as 1 square and the middle term will be in the minus 2ab form, or in other words it is a minus b the whole square. A square b square minus 2ab, or in other words it is this. So there x minus 1 is a factor. So it works both ways. If x plus a is a factor, minus a is a 0. Now it's time to wind up today's class. Let me tell you what we are going to do in the next class. Here you have a bigger polynomial of the degree 3 and a smaller polynomial of the degree 1. Now, is qx a factor of px? How do you find out if something is a factor of a bigger number? How do we do it for numbers? How do we check if 2 is a factor of 10? How do we do that? We divide p of x by q of x. Then everything depends on the remainder. How? If the remainder is 0, then yes, qx is a factor of px. If it is not 0, if it is 1 or 2 or 3, then it is not a factor. But for that we have to divide. In the next class we will learn a wonderful theorem using which you don't have to divide. Even without dividing, you can find out what the remainder is. It is called the remainder theorem. It is called the remainder theorem, and what does it state? It states that if you have a bigger polynomial px and a smaller linear equation, say x minus a, then when you divide px by qx, its remainder will be p of a, or in other words, wherever you see x, you put a, then that will be your remainder. You don't have to divide. You can straight away find what the remainder is, but that is for another day. Till then, Assalamu alaikum.